All right, welcome to the Explainer. Today we are going to tackle something that's super elegant in Python, but also, let's be honest, kind of confusing sometimes, decorators that actually take arguments. Okay, so let's just dive right in. You've probably seen a standard decorator, right? Super clean, super simple, you know what it does. But then you see this thing. The one with parentheses and arguments, and suddenly it's like, wait a minute, the rules just changed on me. What is this?
And that right there, that's the question that trips up so many people. It's the big mystery we're going to unravel today. And the answer, well, it's actually way more elegant than you might think. It's a really beautiful example of just how Python treats its functions. So, to get there, we've got to tackle this decorator dilemma head-on. And that means we need to take one quick step back and remember what a decorator really is under the hood.
Right? That little @ symbol, the @, we call that syntactic sugar. It's just a fancy term for a shortcut, a much cleaner, prettier way to write something that's actually a bit more involved. And this is what's really going on. That @ symbol is just a shorthand for this line of code. At its core, a decorator is just a function. It takes another function as its input, does something to it, and then hands back a new modified function. That's it. That's the fundamental rule we got to remember.
Okay, foundation set. Now for the main event. What in the world happens when we throw those parentheses and arguments into the mix? Okay, here it is. This is the secret. That line with the arguments, it's not actually the decorator. It's a function call. A function call that returns the real decorator. So Python sees that line, runs the function first, and then it takes whatever function it gets back and applies that as the decorator. It's a two-step process.
Let's trace this out step by step. First, Python calls that outer function with your arguments, foo and bar. Step 2, that function's only job in life is to return the actual decorator function. And then finally, step 3, Python takes the function it just got back and applies it to your function, just like any other simple decorator. See, it's this really clever little sequence.
And this pattern is so common and useful, it actually has a name, a decorator factory. I love this name because it's perfect. Think of it like a machine. You feed it your custom settings, those are your arguments, and it churns out or manufactures a brand new decorator built to your exact specifications.
All right, hopefully that was a bit of an aha moment. Now let's look at the actual blueprint. How do we build one of these things in code?
Okay, brace yourself. It's going to look a little complex at first, because to make this work, you need 3 nested functions, one inside the other. But stick with me here, because each layer has one very specific, very simple job.
It really is like a handoff or a relay race. The outermost function, the factory, its only job is to grab those arguments, foo and bar. Then it hands off to the next function, the decorator, which grabs the function we're decorating, like our hello function. And then it hands off one last time, returning the final wrapper function. That's the one that actually runs when you finally call your decorated function with its own arguments, like Bob.
Okay, so this pattern is incredibly powerful, but we can't stop here. If we do, we're going to fall into a super common trap, one that causes some major headaches when you're trying to debug your code later.
Think about it. We wrapped our original function inside another function called wrapper. So, what happens to our original function's name? It's docstring. All that useful stuff.
Well, if we actually check, we'll see that our decorated function doesn't think its name is hello anymore. It thinks its name is wrapper. Its docstring is gone, replaced by the wrapper's docstring. And for things like debuggers or help tools, this is a huge problem. Our function has lost its identity.
Yeah, without the right fix, you fall right into this metadata trap. It's super subtle, but man, it is dangerous. It can make debugging an absolute nightmare later on when you can't figure out why your function isn't reporting its own name.
But thankfully, Python has our back. The standard library has the perfect built-in solution for this exact problem. It's a decorator called wraps, and you'll find it in the functools module.
And here's how you use it. You apply it as another decorator, right on top of your innermost wrapper function. It's like a decorator for your decorator. You passed it the original function, f, and it does this brilliant little bit of magic where it copies all that important metadata, the name, the docstring, everything, from the original function over to the wrapper. Problem solved.
All right, now that we've added that professional polish, let's put it all together and see this thing in action with a real practical example. Yeah, kind of inspired by the philosophy as something like the Python cookbook, which is all about practical, useful recipes. We can build a really flexible tool here. Something that's powerful, but also super easy to reuse across our code. So let's say we want a decorator that can multiply the result of any function by a number we give it. In this case, we're using @multiply5. So we want it to run our sum function with 4 and 6, get the result, and then multiply that result by 5. And bam, there it is. The sum function does its thing, returns 10. Our decorator, which has been patiently waiting, intercepts that 10, multiplies it by the 5 we gave it earlier, and then returns the final answer, 50. It's just so clean, so configurable, and you can see how powerful this pattern is. So let's zoom out. After all that, what's the really big idea here? What's the main takeaway? It's that decorators aren't magic. They aren't some weird, special syntax. They are an elegant pattern that's only possible because of how Python is designed. In Python, functions are what we call first-class citizens. That just means you can pass them around, return them from other functions, and store them in variables, just like you would with a string or a number. And that single idea unlocks so much power.
Think about the possibilities. You could use this for logging, for timing how long a function takes, for checking data types, for handling authentication. The list goes on and on. You now have the blueprint to build your own flexible, reusable tools. It really opens up a whole new way of writing cleaner, smarter, more powerful code. So the only question left is, what are you going to build with it?